Welcome to ThinkViL educational videos. In this video, we will learn about mass block motion and force and friction, covering their theory, key concepts, important formulas, and practice questions. First, let's understand, what is mass block motion? Mass block motion is the movement of a solid object due to push or pull forces on a frictional or frictionless surface. It follows Newton's laws, with friction affecting motion and acceleration depending on the net applied force. Mass block motion ThinkViL simulation is based on the concept of mass block motion. Now, what is force? Force is a push or pull acting on an object that causes it to move, stop, or change direction. There are different types of forces. The first is applied force, which is a push or pull exerted by an external source, causing an object to move or change direction. For example, push or pull a block using your hand. Now, normal force. Normal force is the force exerted by a surface to support an object resting on it. And it always acts perpendicular to the surface. For example, a block resting on a surface experiences a normal force in the upward direction. Now, frictional force. Frictional force is the force that opposes the motion of an object when it comes in contact with another surface. It acts in the opposite direction of the movement. For example, a block on a frictional surface with an applied external force experiences a frictional force in the backward direction. Now, let's understand what is friction. Friction is a force that resists the motion of an object when it comes in contact with another surface. It acts in the opposite direction of movement and depends on the roughness of surfaces and the normal force. There are different types of friction. Now, first is static friction. Static friction is the force that prevents an object from moving when an external force is applied. It acts between two surfaces at rest and increases until it reaches its maximum limit. Now, consider a block on a frictional surface with an applied external force. If the block does not move, static friction acts in the backward direction. For a stationary object, the static friction force adjusts itself based on the applied force, up to a certain limit. Therefore, static friction is less than or equal to the product of the static friction coefficient and the normal force. When the static friction force reaches its maximum value just before the object begins to move, this is called the maximum static friction force. Let's understand static friction force and maximum static friction force by using mass block motion ThinkViL simulation. For access the simulation, visit www.thinkvil.com. Now, open the simulation. You will see this layout, a mass block with some mass resting on a frictional surface. For this block, the maximum static friction force is 30.6 Newton, meaning the block will not move until the applied force exceeds this value. Now, observe that as we increase the applied force, the static friction force also increases. This means the static friction force adjusts itself according to the applied force until it reaches the maximum static friction value. If we exceed the maximum value, the block will start to move, and the kinetic friction force will be applied. Now, for a block, if push or pull forces are applied in the horizontal direction, we can determine the forces using these formulas. Now, if forces are applied at an angle, we can determine the forces using these formulas. Now, kinetic friction. Kinetic friction is the force that opposes the motion of an object already in motion. It acts between two moving surfaces and remains constant as long as the motion continues. It is always less than maximum static friction. Now, Consider a block on a frictional surface with an applied external force. If the block moves, kinetic friction acts in the backward direction. Here, kinetic friction is equal to the kinetic friction coefficient multiplied by the normal force. Now, for a block, if push or pull forces are applied in the horizontal direction, we can determine the forces and acceleration using these formulas. Now, if forces are applied at an angle, we can determine the forces and acceleration using these formulas. Let's understand the concept with an example. In mass block motion, a block with a mass of 5 kg is resting on a frictional surface with static and kinetic friction coefficients of 0.6 and 0.5, respectively. If the block is pushed with a 50 Newton force in the horizontal direction. Now, determine the acceleration, normal force, and friction force acting on the block. Let's first visualize the question in mass block motion ThinkViL simulation. Now, open the simulation and enter all the given inputs. Before solving the question, first we need to check which type of friction will act at the given force. To do this, we check the maximum static friction, which is 29.4 newtons in this case. Since the applied force is greater than this value, the block will start moving, meaning kinetic friction will act. Now, choose the applied force as the push type and gradually increase the force. Once it exceeds the maximum static friction, kinetic friction will act. At 50 Newton, we will get the all required values. To observe the motion, start the simulation. Now, let's solve the question by using the formulas. Here, the normal force is equal to the mass multiplied by gravity and acts perpendicular to the surface. Now, let's determine the maximum static friction force to identify which type of friction will be act at the given force. Here, we found it to be 29.4 Newton. Since this force is less than the applied force, the block will move and kinetic friction will act. We calculated the kinetic friction to be 24.5 Newton, acting in the opposite direction of the movement. Now, we can calculate the acceleration by using the formula. After performing the calculations, we obtain the same results as in the simulation. For practice more questions, explore ThinkViL questions. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.